Okay, for example, let's evaluate the double integral of 4xy over r, where r is the region in the second quadrant enclosed by the circles x squared plus y squared equals 1 and x squared plus y squared equals 4. Okay, so we will evaluate this double integral using polar coordinates. So as a first step, actually kahit hindi sa polar coordinates, let's try to sketch this region R. So before I give the figure, try to imagine yung region is the region between this circle centered at the origin of radius 1 and this circle centered at the origin of radius 2. So yung nasa gitna ng dalawang circles na to na nasa second quadrant lang. So yung ating region looks like this. Ayan, so may sketch na tayo ng region. Tapos identify lang natin yung mga curves na to in polar coordinates. So etong circles na to, parehas silang centered at the origin. So, yung equations nila in polar coordinates ay r equals yung radius nila. Or in particular, this is r equals 1, tsaka r equals 2 in polar coordinates. Ayan. So, with that, itong given na double integral natin, in polar coordinates, so una yung integrand natin, yung 4xy, convert natin to polar coordinates by replacing x by r cosine theta and y by r sine theta. Tapos, yung dA, again, recall, sa polar coordinates ay r dr d theta. Ayan, tapos, to set up bounds for r, balikan na natin yung region, try to imagine or draw strips coming from the origin papunta sa region natin. Ayan, so yung unang matatamaan dito, yung r equals 1. So, dahil dyan, yung lower bound ay 1. Tapos, yung huling matatamaan, before exiting the curve ay yung r equals 2. So, yun yung upper bound, r equals 2. Tapos, yung bounds natin for theta, tingnan lang natin yung angles covered nitong region na to. So, looking at this, tapos again, theta is measured counterclockwise, so that theta is from pi over 2 to pi. Ayan, so ganun mag-set up ng bounds in polar coordinates. Okay, tapos to evaluate this double integral, simplify lang muna natin. So, magiging 4r cube, kasi may isang r dito, cosine theta, sine theta. Tapos, to evaluate this double integral, may parang sa rectangular coordinates lang din. We start with the innermost integration. So, integrating this with respect to r, we get r to the 4 cosine theta, sine theta. Tapos, evaluating at the endpoints, at r equals 2, this is 16 cosine theta, sine theta. Tapos, minus at r equals 1, cosine theta, sine theta. Tapos, subtracting those two terms, we end up with 15 cosine theta, sine theta. Tapos, integrating next with respect to theta, gamit lang tayo ng u substitution to integrate this so that an antiderivative for this function ay 15 halves sine squared theta. Tapos, evaluating sa endpoints, we get negative 15 over 2. So, yung last steps dito, parang sa rectangular coordinates lang. So, again, start lang sa innermost integration, tapos integrate with the next variable. Ayan, so ganun lang mag-set up ng bounds using polar coordinates. Okay. Before we move or we do another example, let's look at this region. So take note, without polar coordinates, kung gagamit tayo ng rectangular coordinates, so that's using either horizontal or vertical strips, kung gagamit tayo ng vertical strips, kailangan i-split na natin itong region into two subregions dahil nag-iba yung lower curve. Similarly, kapag horizontal strips yung gusto natin gamitin, i-split pa rin natin to into two subregions. So, in either case, kapag gusto natin i-evaluate tong double integral using rectangular coordinates, medyo makalat, diba? So, in this example, ang pinaka-okay talaga na gamitin ay polar coordinates para i-evaluate itong double integral na to. Okay, next, let's do this example. Let R be the region in the first quadrant between x squared plus y minus g squared equals 9 and x squared plus y squared equals 36. So with that region R, let's evaluate the double integral of x over R. Okay, so again, kailangan natin ma-sketch yung region of integration before setting up the bounds. Okay. So, before I give the figure, try to imagine first, the first curve is a circle centered at the point 0, 3 with radius 3. So, ito, nasa y-axis yung kanyang center. Tapos, dahil 3 rin yung radius niya, this circle will be tangent to the x-axis. Tapos, ito ay circle centered at the origin with radius 6. So, try to imagine or draw the region between them. Tapos, kunin lang natin yung part na nasa first quadrant. So, in the end, we will get something like this. So, ito na yung region natin. So, next, let's identify the curves in polar coordinates. So, because of the scenario of this circle, from our recall earlier, ang equation nito ay r equals 2a sine theta of that form, diba? Where a, again, is yung radius. So, that ito ay r equals 6 sine theta. Similarly, itong circle sa labas, yung mas malaking circle, centered at the origin yan, so r equals 6 lang ang kanyang equation. So, ito na yung ating curves in polar coordinates. So, evaluating or setting up at least itong double integral natin in polar coordinates, we have the following. So, una, yung x, magiging, again, r cosine theta. dA becomes r dr d theta. Tapos, for the bounds, tingnan natin yung region. For bound for r, drawing strips or imagining strips from the origin to the region, ang unang matatamaan ay r equals 6 sine theta. So, yun yung lower bound, 6 sine theta. Tapos, yung huling matatamaan before exiting the curve ay r equals 6. So, again, bounds natin for r from the inner curve, 6 sine theta, to the outer curve, r equals 6. So, next, for the bounds for theta, tingnan lang natin yung angles covered ng region na to. So, based dito sa sketch natin ng region, theta will be from 0 to pi over 2. Ayan, so yan ang setup ng double integral na to in polar coordinates. So, evaluating this by first simplifying the integrand, magiging r squared cosine theta. Tapos, the next steps, again, same as before, matagal na natin ginagawa to. Integrate with respect to r, innermost variable, and evaluating sa endpoints, we get this. Tapos, integrating again with respect to theta. For the first term, simpleng formula lang. Tapos, for the second term, u substitution. In either case, an antiderivative for this function is this function. So that, evaluating at the endpoints, we get 54. Okay. So again, to set up bounds for a double integral in polar coordinates, kailangan ma-sketch natin ang tamang region. Tapos, again, for bounds for r, imagine or draw radial strips coming from the origin. Tapos for theta, kailangan lang malaman yung angles covered. So take note, yung theta lagi dito yung outermost integration so that yung outermost bounds laging constants dapat. Okay? Pero in general, yung bounds for r can be any function of theta. Okay? Okay, next example, let's evaluate this double integral using polar coordinates. So, may given na sa atin na double integral, naka-set up na yung bounds na in rectangular coordinates. Pero the thing is, gagawin natin, evaluate natin to in polar coordinates because kung ito mismo yung gusto natin i-evaluate, uunahin natin yung integration with respect to y, di ba? Pero you can imagine, ang integral nito with respect to y, hindi siya given by some of our basic formulas. Tapos, mukhang wala ring u substitution na gagana dito. So, mukhang mahirap to integrate. Either siguro gagamit pa tayo ng some trick or some more advanced na integration technique na kung siguro ayaw na natin balikan, try natin i-evaluate na lang to instead using polar coordinates. Tapos, kung kahit baliktarin natin yung order of integration, kahit somehow mabaliktad natin to gawing dx, dy, we have the same problem, di ba? Mahirap pa rin siya ma-integrate with respect to x. Okay, so dahil dyan, we will use polar coordinates. Okay, so para pa-convert muna to polar coordinates, actually, in process, parang sa reversing the order of integration. First, we draw or we sketch the region of integration based dito sa bounds na given sa atin. So first, because dy dx yung ginagamit dito sa given na double integral, this region can be seen as a type 1 region na merong lower curve tsaka upper curve. Based sa bounds for y, ang lower curve ay y equals 0, which is the x-axis. Ang upper curve ay y equals square root of 8 minus x squared, which is, pag nire-write, the same as x squared plus y squared equals 8 so that yung graph nito ay isang circle. Well, actually, yung upper half ng circle na to. So again, yung lower curve natin or yung lower bound ay y equals 0, yung x-axis. Yung upper curve ay isang semicircle. Tapos x is from 0 to 2 square root of 2 lang, which is yung radius ng semicircle. Okay, so with those bounds, yung region natin looks like this. So again, lower curve, y equals 0, yung x-axis. Upper curve, yung semicircle. Tapos x is from 0 to 2 square root of 2. So with this region, kaya na natin i-convert ito into polar coordinates. So, paano yan? So, una, yung integral natin, again, i-convert muna natin to polar coordinates. So, recall, yung x squared plus y squared in polar coordinates ay r squared. So, our integrand becomes this. Tapos, yung dy dx, yun yung dA, diba, sa rectangular coordinates. So, pag ginawa nating polar coordinates to, magiging dA in polar coordinates, which is yung r dr d theta. Ayan, tapos dahil may sketch na tayo ng region, we can set up bounds for r and theta. So again, for r, drawing strips from the origin up to the region, makikita natin na starting from the origin pa lang, natatamaan na agad yung region. Kapag ganun, r will start from 0. You can also think of it this way. Yung graph ng r equals 0, yung origin lang, di ba? So, from the origin, with equation r equals 0, ang outer curve natin naman ay r equals 2 square root of 2, which is this circle centered at the origin of radius 2 square root of 2. Ayan, so yun yung bounds for r. So again, from the inner curve, the origin, to the outer curve, r equals 2 square root of 2. Ayan, tapos yung bounds for theta, again, counterclockwise ang pag-measure, so theta is from 0 to pi over 2. Ayan, so again, to convert to polar coordinates, sketch lang yung region based sa bounds. Tapos, ayan, kung may sketch na ng region, convert nyo lang yung integrand tsaka yung differential in polar coordinates and use the region para sa setup ng bounds. Ayan, so sinasabi natin dito na equal lang itong dalawang double integrals na to. So, yun yung evaluate natin, yung naka-polar coordinates na lang. Pero the thing is, dahil dun sa r dr d theta, mas madali na itong ma-integrate. Gagamit lang tayo ng u substitution. We let u equals r squared plus 1, so du equals 2r dr, and so on. Okay, so using that u substitution, our innermost integral becomes this. Ang bagong bounds for u ay from 1 to 9. Okay, tapos same steps, integrating with respect to u, evaluate sa endpoints, integrating with respect to theta, and evaluating sa endpoints, we get this answer pi. So take note, yung original na given sa atin, mahirap ma-integrate directly, pero somehow using polar coordinates, na-integrate natin to using just u substitution. So this is one advantage of polar coordinates over rectangular coordinates.